Welcome everyone to our July NDPTC third Thursday webinar series. I'm not sure. I think everyone got the flyer. There was a typo on the flyer. It's not about Mauna Kea. We had a Mauna Loa eruption, right? So today's speaker, also on the flyer, there was, we had two speakers. Dr. Bruce Houghton is actually in Iceland. I think he's doing some field work at the volcano that's erupting there. So we have one speaker today, Dr. Ken Hahn. He's a scientist in charge of the Hawaii Volcano Observatory, which is part of USGS. So he will talk about both volcanoes eruptions, the Mauna Loa and the Kilauea eruption. And not sure, I guess, Dr. Hahn, if you're involved with the Converse project that's led by University of New Mexico, I'm not sure how engaged you are with that. I know Bruce is one of the co-PIs on that.
I'll let Bruce speak for that when he's ready.
Yeah.
That's a whole nother issue. So
yeah. So we'll have you talk about the two volcano eruptions, and then we'll leave the questions for the end of the session. So you can share your screen and start the session.
Okay, thank you very much, and thanks for inviting me here. Get this shared here. My screen up. Okay, so are you guys seeing the full screen, or do you still see my slides on the left there?
Slides on the left.
Ah, okay, so it popped it over to a different screen. Okay, so this will take just a second. Gotta unshare that, I guess. Reshare the other screen. Okay, so now do you just see the slides?
Yes.
Okay, great. So thank you for having me here. And what I'm going to talk to you about today is kind of what the mission is of the USGS in terms of volcano hazards, also what we do at the Hawaiian Volcano Observatory, and talk about the kind of different eruptive activity that we've had over the past couple of years. We've gone from eruptions that usually take a few days to kind of, they give us a few days of warning and a few days to unfold, to these things that we're calling kind of hair trigger eruptions. So we've had 4 of these at the summit of Kilauea, and then of course the big Mauna Loa eruption. And they present some real challenges for us as an observatory. And also I want to emphasize how we work with the emergency managers during these as well. So we'll go on to the, let's see if we can get to the next slide here. I guess I'm going to be on this one. Okay, so the mission of the USGS is really to keep the public safe. That's the #1 thing when we do hazards. And then also to minimize as much as possible the social and economic disruption of anything caused by eruptions. And we do that by a large part by hazards assessments and education, along with forecast warnings and other information based on our understanding of volcanic processes, which requires something that continually changes, right? If we were still using the same ideas we had about Kilauea 100 years ago, it would be very difficult to do our jobs today. So we've gotten a lot of data since then, and we have a lot more equipment than people had 100 years ago. So it's not to be unexpected that we're a little bit better at understanding the volcanoes. So the Hawaiian Volcano Observatory really consists of kind of 2 sets of people. We have people that are dedicated for monitoring the volcanoes and people that do research. And so these 2 things work hand in hand together. I mean, we interpret the geologic and geophysical events, and that leads to eruption forecasting and hazard assessments. we also refine and understand the models so that we can apply that data correctly and come up with the correct answers, right? So both of those things need to be there as components. We are not only, we're unusual for Volcano Observatory in that we're not only the official group of people that has been tasked with monitoring volcanic hazards and volcanic eruptions in the state of Hawaii, but we're also tasked with monitoring the earthquakes across the state. So no other US Volcano Observatory is also the earthquake monitoring body as well. So we have like a kind of a dual mission here in Hawaii. I'm going to talk mainly about our volcanic hazards and eruption part, which relies heavily on earthquakes because that's the #1 way that we're able to track magma underground and be able to forecast eruptive activity. So one of the things that we do here very well, I think, and have HVO has a long history of it, is working well with all the agencies that we intertwine with here in the state of Hawaii, and particularly the local agency, particularly both Hawaii Volcanoes National Park and Hawaii County Civil Defense. So I've been here for a long time on the island. I don't even want to talk about how long I've been here, but you know, every time somebody changes at one of these agencies, you need to develop a new relationship. You're unknown to the new people. And so a lot of what we do is develop these relationships, and then you have to develop trust. And trust only comes about by showing people that you can do the job, right? And working with them closely and giving them information they can rely on. As emergency managers, you don't want information that you can't rely on, right? You have to make some decisions about risk and about public safety. And it's really important that there's a trusting relationship prior to an event unfolding, because this really makes it a lot easier for information to be communicated and to make sure that we get accurate information to the public, and that all the public officials, emergency managers, have the correct information and understand it so that they can make the appropriate decisions. As the USGS, we're primarily involved in hazards assessment rather than risk assessment, right? And the risk assessment really is the business of both the Hawaii County Civil Defense, HIEMA, FEMA, right? We do, when asked, have input into the risk assessment, but that is not one of our primary things. So we want to avoid that conflict. We're bringing in the hazards part of the information, and then the risk has to be assessed separately from that. So it's real important that we all understand what our roles are, and that's really important so it doesn't get confused during an eruption. That basically it's stay in your lane, right? And we do a lot of behind the scenes talking. We're asked about risk assessments and things like that. So we do go into that, but only when asked. So this is a picture that I don't expect anybody to memorize, but this is our monitoring network on the Big Island. It's composed of, as you can see over there, a bunch of different things: cameras, gas monitoring stations, GNSS or GPS stations that do locations, and then also seismometers. And all the little lines that connect them have different colors. They're all connected by various networks. And as you can see, this is not a simple kind of network of instrumentation that we have out here. It's very complex. And it was luckily redone during the ARA period in the Obama administration when there were extra funds. We redid our network. It used to be that all those lines went right to the summit of Kilauea to the Hawaiian Volcano Observatory. If that would have been true in 2018, that eruption would have shut down all the monitoring on the island. But we have some very smart people that you can't really tell how this is set up, but think of it as kind of the Olympic rings, that our information from all these monitoring stations runs on ring-like tracks. And those rings intersect each other at different points. And so we can jump the information from one ring to another one. So say an eruption takes out a piece of one ring, then we still have other parts of the ring. We can back the information up and jump it to another ring and get it back so that we can look at it. And all of our information actually goes to Kauai now. It doesn't show that on here because it goes through computers over there. We have all of our servers in Kauai at a Hawaiian Tel facility that's up at about 200 feet elevation, out of the tsunami zone, and it's in the least affected part of the island for both earthquakes and volcanic eruptions. And it's also close to where the internet connection comes up out of the ocean. So it's got the most direct access to the rest of the world. So we did a lot of that kind of stuff in response after 2018 as well, to make sure that we have secure data, which is really important, and that it won't be affected by the eruption. Because as you know, our observatory got shut down in 2018. It was basically destroyed, and it hasn't been occupied since the 2018 eruption. So here's the lead up to the last eruption that was on June 7th. And we've had a series of 4 of these summit eruptions since December of 2020. This is the earthquakes for about a week before that. And we knew that for the previous 2 months that the summit of Kilauea was very unsettled. Right now it's very quiet, but we can see that there's activity in the Halemaumau crater area in here, shown with these orange earthquakes. There was also activity over in here off to the west and up to the north, and we call this Namakani Paio after the campground that's over in here. But this area tends to light up before Kilauea summit eruptions as well. And then down in towards the southwest rift zone, south of the caldera, there's earthquake activity in there. So these are the 2 most likely places that eruptions could occur. So we're expecting some sort of activity. So we are on alert. We're getting a lot of swarms in the week before this, to the point the night before the eruption, we basically got woke up by swarms, which is by definition about 10 earthquakes per hour. And we stayed up from about 9 o'clock at night. We stayed up the rest of the night monitoring the swarms. This next image will show, oops, did I go the wrong way? Ah, there we go. These are the earthquake counts starting in April, leading up to the eruption. And you can see we had some peaks in earthquakes. So there's a number of little peaks, and the eruption peak is bigger, but it's not that much bigger than some of these other peaks. So we had a lot of little ramp ups that we were alerted, and this is kind of a little intrusion that occurred. There's another intrusion back here. So all of these things are going on. The tilt meters, or the summit of the volcano, is going up slowly during that same period. And then the eruption, it really goes up, because what happens is when the magma comes up near the surface, it deforms the surface. So we see that at the start of the eruption in here. So we knew something was out there, but it, just like the Mauna Loa eruption, actually knowing exactly when it's going to happen is difficult to predict. So in Mauna Loa, we gave people a warning a couple months out that we thought that it was likely the volcano would erupt. But we also told them, we're not going to be able to tell you until an hour before it erupts. And that's true with the Kilauea eruptions too. So the Kilauea eruptions have proved a great place to kind of train the staff, to make sure, because the staff hasn't actually had to face these kind of eruptions for many, many decades. And most of the staff is new and has never seen these kind of eruptions that have very rapid onsets. And it's also a time that we can build trust with our partners, because we look at these, and while these are contained within the summit of Kilauea, it gives our partners confidence that we're able to tell them in advance that, you know, it's likely there's going to be an eruption, and then give them a little bit of warning, but tell them that, hey, these are going to happen. These are going to unfold really fast. So they play an important role that way. Plus, they're beautiful to see, right? So here's the onset of that. And I don't have anything before, but this is where the lava breaks the surface. But this is the hour prior. Before this, it was pretty quiet. All these little red lines in here are earthquakes happening. And what you can see is the hour before the eruption happens, we have lots of earthquakes, and they intensify. And basically, if you want to think of seismicity as noise, this is the sound of the ground cracking open at depth as the magma proceeds to the surface. So it's going pop, 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 pop as it breaks open a fissure. The fissure opens up, and you notice the popping stops really fast. And we get the red is all down in here in these very low frequencies. These are frequencies from about 5 to 25 hertz, things you can't hear unless you're an elephant. But the seismometers pick them up. And we also have some other instruments that can pick them up as well. So this noise that we see afterwards is what we call tremor. And it's basically ground shaking. And what it is the vibration due to the eruption, what's happening in the eruption constantly is bubbles are forming in the magma expands, then the bubbles are released and it contracts. So it sets up a constant vibration, basically. So this is a vibration in the ground that tells us there's an active eruption. So this is what we're seeing on our instruments, and it helps us pull apart all the earthquake locations, right? We want to look at the types of earthquakes and the frequencies of the earthquakes and things like that. And that's what we're using to look at these things. And I just wanted to show you how slowly the 2018 eruption unfolded. If you look up in the upper left-hand corner up there, we're missing that, looks like the date is out, but that's the 30th of April. And most of the earthquakes are right around Pu'u'o. That's in the morning. The next figure on the top right is in the afternoon. The earthquakes have started to migrate downrift from Pu'u'o. And then we can see early morning of late night and early morning of the 30th and May 1st. The earthquakes have moved even further. And you can see the little orange triangle on that lower left diagram. That's Leilani Estates, where the eruptive fissures opened up. And so they're headed down that way. Now, people, you look at that and you go, that doesn't look like earthquakes are in a line, right? That looks like a big cloud. But really what we're seeing in there, and can you guys see my mouse when I put it on here? Ah, great. So what we're seeing in here is this is where the cracking is going on up here, this line of earthquakes. And what these earthquakes are, this is the flank responding of the volcano. So as the magma goes down through the crack, it's pushing it apart. It can't push the north side very much because there's the rest of the island. It pushes the south side seaward. And so we get earthquakes there as the south side goes seaward. And then you can see when it actually gets down in the 1st to the 3rd, it's down in here and it's continuing to push. And if you remember, the next day we had a magnitude 6.9 earthquake. We had a couple 5.5s in there. That's the flank actually popping and really moving seaward. So that makes room, when that pop happens, it makes room for the magma to come up. And that's when we know the game is really on, because it's going. But if you look at this, oops, somehow I managed to move that all. I got to be careful. If you look at this in here, down on the bottom, it shows you the number of earthquakes. There's a lot on the 30th, the 1st, the 2nd, and then they taper off kind of once the eruption starts. So this eruption started, but we're looking at 3 to 4 days of warning before the magma broke out, right? We had lots of time compared to what we're looking at with these summit eruptions of Mauna Loa and Kilauea, where we have virtually no time when the magma starts making it to the surface. It's almost at the surface before it erupts, right? It's only going 2 kilometers. This magma moved about 12 kilometers down the rift zone. So it's kind of a reflection of how much rock it has to break open to get to the surface. Okay. So here's some other ones of these summit eruptions, and what you can see in here, this was the 2020 December eruption over in here. So the first one of the summit eruptions, it's really quiet. And then about an hour before the eruption, bang, 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 all these earthquakes start, and then boom, the eruption starts in here. So we have the onset of the eruption. Here's another one, about an hour. It's really pretty quiet before, and then bam, 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 bunch of earthquakes, and then the eruption starts. So this is the 2021 September eruption. And then here we have the January eruption. Same thing, very quiet, and then bang, bang, bang. But then it was really quiet in here. But, there was actually, I never even had the feeling that we should tell people, oh, maybe that was just an intrusion. We just waited and the stuff popped to the surface because we felt this swarm was tight enough and got close enough to the surface that an eruption was going to happen. But it happened a little bit before, and then it went kind of quiet, and then boom, lava was out on the surface. So it came very close to the surface. So there's some kind of sitting and waiting in some of these. They're not always perfectly understood. Okay, and this brings us to Mauna Loa. This is really what we're training for here, right? Because Mauna Loa, particularly the southwest rift zone of Mauna Loa, is a place where we're really afraid that not only are we going to lose property, but we potentially could lose lives, right? The eruptions can be really fast and furious on that southwest rift zone. And the one that we use as an example is the 1950 eruption that 3 hours after the eruption started, lava was down in the ocean. It went through the Ho'okana post office. I mean, there wasn't much else out on the Southwest Rift Zone, but it managed to hit the one town post office that was out there and took out 4 or 5 houses within 3 hours after the eruption started. So conceivably, and it started in the middle of the night, as most Mauna Loa eruptions seem to like to do. So we're really worried about people being able to get out of the way of those lava flows. And it's not like what we really wanted to stress when we went into here. We had some important things that we knew from the 2018 eruption that we needed to control and stress the communications with the news media and with social media, right? The 2018 eruption, as you remember, got a bit out of control, that it impacted the tourism industry across the entire island chain, right? Impacted everybody because people thought the entire island chain was basically under lava from what the press was reporting and from how people were saying how big, and it was a large historic eruption. It destroyed a lot of houses. It had a terrible impact on the communities it impacted, but the area it actually impacted was relatively small, right? And also confined. But, you know, even I was working for the university at that time period, and the chancellor that I was working for asked, well, how do you know it's not, is it going to come to Hilo? How do you know it's not going to come to Hilo? And it never even occurred to me that somebody would think that, you know, because Puna is separated and the downhill, it can't go downhill from there. But people just don't understand volcanoes very well. To a lot of people, lava can just pop up anywhere out of the ground and it doesn't make any difference. It just shows up. So we wanted to control that kind of messaging, that even if it comes down the Southwest Rift Zone, it's going to be in a fairly confined area. The thing we want to do is make sure that you're not in your house unaware when that lava comes down the hillside, right? The other thing we wanted to do in this is make sure that we kept control of the message. We didn't we didn't make these things seem bigger than they were. And we made sure that we controlled the message so that people didn't get the idea the lava was coming to this place or that place, right? So the first 6 hours of this eruption, in the early morning hours from when it started just before midnight to about 5:30 in the morning, we didn't know it. All Mauna Loa eruptions start at the summit, and 50% of them remain in the summit. About 25% go either way. So we can go down and take a look at that. Here's a bunch of the historic eruptions in here. The summit area is bigger than the caldera. My mouse is making changes on its own. The summit area is bigger than the caldera in here, and it's shown as this dashed red line. But this is where eruptions start, is up in this area, and then they can go down one or the other rift zone. The northeast rift zone up in here is unpopulated till you reach the outskirts of Hilo way down here. So it takes a while for lava to get down there. Typically, the earliest lava could get there from an eruption is about a week. Whereas we look at Mauna Loa, the slopes are much steeper on the side of Mauna Loa. And here's the 1950s shown in this gold color. This lava flow right here went through Ho'okana. It was in the ocean in something like 3 hours. This lava flow, I believe it was about 14 hours. And this one got into the ocean, I think it was about a day and a half after the eruption started. So this is really rapid when you're talking about trying to get people out of this area. But the other thing to keep in mind is the populated part of Mauna Loa is way down here close to the ocean, right? The belt road is like almost on this picture, almost at the ocean. And so the upper parts of Mauna Loa are big. So during that night when the eruption started, people saw a lava flow come out of the summit. And we've had lava flows. There's been 1949 lava flows came out of there, 1950 lava flows came out of there, 1851 lava flows, but they didn't get anywhere near populated areas. But from Kona, it looked like all craziness was going, and people thought that that was an area that this lava flow might actually be headed down the Southwest Rift Zone. When we went out, we told people too that it's possible that like the eruptions and what happened in here is this eruption in last November did the same thing the 1984 eruption did. It threw a head fake. It went to the south and appeared more active at the south end of the summit. But then the eruption actually broke out on the northeast side. So people, we tried to let communities know that until we actually tell you which rift zone it's going into, until the volcano commits, there's no way that you're going to know, right? Now, people could self-evacuate beforehand, and a number of people did. They drove into Kona and went out to a shelter that Civil Defense had out by the old airport out in there. And they also, they opened a shelter over in Pahala as well. So there were two ways to go out of there, and it's not a bad idea if you want to go someplace else and just sort of wait it out instead of waiting for the lava to actually be coming towards your house. But we do know something about this, that the last 3,000 years eruption in Mauna Loa have been every 6 years. This last eruption, it was 38 years between the 1984 eruption and the 2022 eruption. So it's a much longer period. We're in this very strange period of activity for Mauna Loa where we have these very long time periods between the eruptions. And as I said, about half of the eruptions, all of them start in the summit, about half of them stay in the summit, 25% of them go down the Northeast Rift Zone, and 25% of them go down here. There's a very small percentage of them that can come out on the sides out here. And, clearly those vents can even start way down on the flank on these side radial vents, like as the 1877 eruption actually happened in Kealakekua Bay. There's also one of these vents at Pu'uhau, a place where there's a new housing development around that vent right there. So they show up, there's a number of these vents all through this whole area. The actual town of Kailua Kona over in here is on Hualalai. So Hualalai provides kind of a shield from Mauna Loa lavas for that. This is just showing the times it takes to reach the ocean in here. So you can see 3 hours, 14.5 hours, 18 hours, 24 hours, 4 days is the longest, 29 hours, 3.5 hours, right? So we're looking at really short periods. To go over to Hilo, lava flows into Hilo, we only have one. It took 280 days, but the 1984 lava flow got down here in about a week, just outside of Kaumana. The 1859 eruption took 8 days to get to the coast, but it would have crossed the upper highway and the lower highway before that. This eruption actually lasted almost a year. So you can imagine the disruption on the Kona coast if both of those roads were cut by an active lava flow for almost a year. It would be pretty strange. So we saw some indications that Mauna Loa was in a period where it looked like it was likely that it could erupt. And we saw this for a couple different reasons. But so what we wanted to do was get this out, but not get it out in a way that looked like disaster was imminent. The island of Hawaii is going to go under lava and everyone's going to die, right? We wanted to make sure that we got the message to the community that how serious this would be for their individual community, and they should be prepared, to get their most important belongings and themselves clear. But all we could tell them is that we're in this period of what we called heightened unrest, right? That where we thought it was likely that an eruption could emerge at any time. And we said, we're probably only going to have about an hour of warning because historically that's the warning that we've gotten. So this is a difficult thing for people to handle because it puts them in a state of anxiety for a number of months. But it's kind of like you've got to think of this as like the weather is such that, a tornado could form or something like that. And you don't have much warning before the tornado forms, but you tell people that we're in a weather system. It's just that volcanic weather systems can last for months, right? They're, and even longer than that. But we saw these signs in mid-September to late October. And so one of the things we did, we tried to tell people what we did know and what we didn't know when we went out to the communities. We knew that the eruptions would start at the summit. We knew that there was about a 25% chance that it could go down the Southwest Rift Zone, right? And that's enough of a chance. I figure anytime you're dealing with volcanoes and you can count some sort of probability like that, then you should take it very seriously. And especially a 25% chance, people need to be prepared. They need to be aware. And so we got a lot of things out in the news. We worked on social media. We really tried to guide that narrative with the news media, so it didn't get out of control. The news media kind of fed on the 2018 eruption. And this is something we talked about very much. We've been working with Civil Defense for the year before this, working on an eruption plan and talking about these things. And we also wanted to make sure in 2018, there was kind of combative situation between, I would say the government agencies and social media. We wanted to make sure that that didn't happen during this eruption as well. So this is kind of balance where you're trying to reduce alarmism, but still get the seriousness of the situation to the people that might be affected, right? So it's a balancing act as you go down through that. Well, here's kind of what we were seeing in the lead up. This is from the year 2000, number of earthquakes on the top graph in here. And it's just showing in about 2014, the earthquakes started to pick up. And then they kept picking up. And then when I first came on in this job in the winter of 2021, 2021, we had a kind of a little peak of earthquakes in here. And I went around and I didn't, it wasn't something we thought that an eruption was imminent, but I went around to the agencies, both HAIMA and the National Park Service and Hawaii County Civil Defense and stuff, and started talking about, hey, Mauna Loa is, it's shaking a little. It's telling us it's there, right? And we need to watch it closely. So everybody should keep an eye out at, because we're talking about the waking up of a sleeping giant. Sorry, every time I move the mouse, it seems to change this. The bottom one is the GPS measurements, and they're showing that the volcano was, since about 2014, started to really inflate again. So it started to blow up like a balloon, right? And so all of that was, something that we were looking at. And then that last red line is the red line from September, middle of September to November 2022. And so both the inflation really picked up and the number of earthquakes really picked up. So these were the things. I'm going to just skip this one. Let's see. Yeah, so these are the things that kind of keyed us into it. And this is kind of a complicated graph. It perhaps shows best on the lower left graph, the number of earthquakes that are happening down there. And you can see on the far left-hand side, that's back in the summer. And you can see the earthquake density isn't as great. These are earthquakes with depth underneath the summit of Mauna Loa. And what you can see is that density really picked up in September, and then we kind of had some little gaps and sporadic, and then you can see the eruptions start with that really very dense line of earthquakes. What we saw up there were two things. We saw this big increase in seismic activity up to where we were getting hundreds of earthquakes per day. And at the same time, the summit rapidly inflated. And we have a tilt meter at the summit who before this hadn't ever said anything, hadn't done anything, hadn't shown us anything. And that tilt meter started going up. And so what that told us when we modeled this is that magma had left the deep magma chamber and was injecting up in the shallow parts of the magma chamber and moving towards the surface. So we knew that magma now was really close to the surface, within probably 2 kilometers of the surface at that point, instead of 3 to 4 kilometers down. And so that's when we kind of started pulling the alarm bells. And the first, when we talked to the park in early October, they said, well, should we evacuate the summit of Mauna Loa? And we said, well, I don't think you need to evacuate it, but let the people come out and shut it down. And they shut the summit down, I think, on the 5th or 6th of October, after the last people that were up there came off of it, and they just left it closed. So they closed all the backcountry up there. And then this is when we really went out in a concerted effort, talked to people in Hawaiian Ocean View, went over, talked to people in Kealakekua, talked to people in Pahala, all the people that might be impacted by this. And we also ran a Facebook Live session, and we talked to a lot of other people. We also incorporated some of the social media groups that had been kind of adversarial during the 2018 eruption. And one of the things we did was reach out to them and treated them like other news media and gave them interviews and, worked directly with them, because they have a separate population of people they reached. And so we realized this was a valuable opportunity. And most of the thing, was about, just understanding this is how they make their living. They make their living by the number of views. So they need to have programming. And why don't we be the programming? They can interview and talk to us and we can get our message across. And I don't really care who gets credit for it. I just care that the accurate information gets out to the public. And so Talmadge Magno, the head of civil defense, agreed, and the mayor agreed. And we all went out and talked to various different people. And we made these guys partners, and they were a valuable partner during the eruptive activity, all the way through the lead up and then the actual eruption. Okay, this is the actual lead up to the Mauna Loa eruption. So it had been pretty quiet. The number of earthquakes had gone down. But then we start seeing a little bit of activity picks up at about 8 o'clock that night. And then we see just before 9 o'clock at night, the activity really starts getting heavy. And then boom, we have this. And I think this is actually in UTC time. Sorry about that, but these are actually 9 o'clock UTC. So ignore that. This actually happened, I think, at about 10:30 at night. And then this went off just before 11:30 at night, I think was the timing of it at night. So in the middle of the night, like all Mauna Loa eruptions, the summit erupts, but just shows you how fast the things come on. They're just like boom, and they're on you. And our seismic group, these guys are on it. They're awake and watching these things. We have people up watching them. And so we were able to talk to civil defense and the Park Service to let them know this was coming out. So we went out into the communities to make sure people were aware, as I was discussing, and gave as many interviews as we could, which were quite a few, about this waking up. And I think we got pretty good awareness on the island of the potential for Mauna Loa erupting. Civil defense did a lot of kind of cool things. We had developed a map that is these kind of lava sheds, if you want to think about them, or where lava is likely to go. If this is the summit of the Southwest Rift Zone down in here, and I've color coded some rift zone where a vent could establish. So if a vent establishes in the blue zone, it's going to go down in this blue inundation area. And so Civil Defense had an interactive map on their website. They still do. And they also, we brought maps out so people could find out where their house was, what inundation zone it was located in, what the mile markers on the highway were, so that the police could give out, the police and fire, when they're giving out evacuation notices, could tell you if you're between mile marker so-and-so and so-and-so, you need to turn north on the highway. If you're between this other mile marker, you need to go south, right? And so the other thing that most of these inundation zones were named after Ahupua'a, and they were also numbered. So there's a variety of different ways, but you can see as an eruption progresses down the rift zone, the lava flows will move down the rift zone too. So it takes a lot of monitoring during the eruption to know where the vents established and where lava is going down, to know the area that you need to evacuate. But this is not something that we could tell people in the beginning, right? You can't tell them until it happens where these are going to go down. So we'd let them know the eruption will start at the summit. At some point, it's going to decide which rift zone to go down, and then it's going to decide where to establish the vents. And so these vents typically move during these eruptions. Like during the 1950 eruption, we had one flow go down here, one flow go down here, and one flow go down here. So there were 3 of them as the fissure progressed down rift out in here. There were 3 separate flows in there. So this is basically just repeating the information that we did, and just telling people that we can't tell you where to evacuate until we know where the location of the vent is on the rift zone, right? People can self-evacuate before that, and that's probably the best thing to do when you have some time, is to just go ahead and leave the area until the eruption is over. These Mauna Loa eruptions are going to unfold, like I said, really fast. If it's on the Southwest Rift Zone where the population is, it's going to unfold in less than 2 days, right? So the other thing we had to count on is we're not getting any help, right? Both Civil Defense, Hawaiian Volcano Observatory, we're going to play with the people we've got. Nobody's getting here to help us out in less than 2 days. So we counted on, doing that. So there's a lot of things that go in. We were tracking all this as closely as we could. And one of the things we learned is we probably needed to communicate more frequently than we did. We were sending out messages about once an hour in the middle of the night, but we probably need to do them every 15 minutes or 30 minutes to just let people know the lava is still in the summit. It hasn't started moving out of the summit. And that way we don't create a void where other people's voices step into it with things that aren't supported by factual information. Okay, so one of the things we found out in this as well is we were able to establish actual real-time mapping. Our volcanologists in the field were actually, they used a phone app to get the locations of the lava flow front. And that went directly into the maps that were both at the Hawaiian Volcano Observatory, at Civil Defense, and it actually went directly to the HIEMA maps and the FEMA maps. So everybody got this information. CD was updating their map directly on the web. We, unfortunately, because we have all these little security things, weren't allowed to do that on our maps, but Civil Defense had a map that was accurate there. The other thing we did was we, by a series of events, we found a way that we could afford to put a live streaming cam out. And that used, because I calculated that what a streaming cam uses in a month is somewhere near 1 terabyte of data. And we're using cell phone modems out there. So in case you haven't checked your cell phone plan, try and figure out what 1 terabyte a month cell phone plan would cost. So we found a first responders network that we could do it for a lot cheaper. It still cost about $4 grand to put that monitoring camera out there. And it was a big hit with people, but what we found out after the eruption is that that camera and the real-time maps, we went back and talked to people, it really gave them confidence. Hey, that eruption is nowhere near us. We know where it is now. We can look at it and we can ignore the false flags that people are planting on social media because we can actually see what's going on. So this kind of seeing is believing thing, having that map update in real time, that was a problem in 2018. And having the camera where people could see it and see what was going on at the eruption site in real time. And we had a lot of other, we put up other cameras and stuff like that and showed where the lava flows were and everything. And we had the inundation zones on there. But one of the things that I wanted to make sure that we didn't do during this was forecast where the lava was going to be, because we found in the 2014-15 Pahoa eruption, that created a lot of anxiety, especially if the lava flow stopped before it got to where it was, you know, that people would worry that, oh my God, that, you know, if you look at this picture over here that says webcam with overlay, it says Kaumana inundation zone and Puako inundation zone. The lava flow is kind of on the Kaumana side, so people could say, oh, lava is headed for Hilo. We don't want people saying lava is headed for Hilo, right? And so the message was, lava is coming down the hill. It's going to slow as it hits the saddle and pile up. And while it piles up in there, we don't really know which direction it's going to go. So what we did know is that these eruptions typically last 2 to 3 weeks. We just got to last that long. And one of the things that I didn't communicate the reason for, but when this erupted, we were able to determine the chemistry of the lava immediately. And this may not mean much to you, but it was 6.2 magnesium and 6.2% magnesium. The lowest amount of magnesium in a Mauna Loa eruption we've seen before, or any summit eruption from Kilauea or Mauna Loa, is 6.7, which meant that this is really sticky, cold lava, and it was unlikely to go anywhere once it hit the flat. So we didn't want to get the public upset about that. One thing the public did do, though, is start going up to see it, right? Because it was spectacular. If you got out here and got to see it, it's like really a life-changing event to see lava flows that big coming down the hillside. They are really quite amazing. And the mayor, you got to give him credit. One of the things the social media folks told him is say, hey, everybody always says we're going to build a viewing area and no one ever does it. And when Mayor Roth heard that, within 24 hours, he had worked out with the Army to get that old section of Saddle Road opened as a viewing area. So it was a pretty spectacular response to that. There's just some cars going by. This was before they set up the viewing area. There was a huge traffic jam you know, going up into the saddle. This was driving back down towards the Kona side. On the left-hand side up in here, on the upper left-hand side is a map of the actual lava flows. On the right-hand side in here, the blues and greens is a map of what we were modeling the lava flows at that time. So we had models, we were looking at these models and stuff all the time, but you don't want to put these out because that modeled lava flow almost looks more real than the map lava flow. And people are going to start believing this. And if the model has an error in it, because we can forecast these into the future, right? And we were forecasting them a week out to just see what the lava was going to do. But, you know, there's no guarantee that the lava is going to do what that map says. We were pretty close, but it's something that, you know, we wanted to make sure that we use that in to provide the background information, but we didn't share that with the public because when those were shared during the Pahoa eruption, then people assumed that's where the lava was going to be, right? And it gave people false expectations. So we were trying to avoid that. We measured the lava like 3 to 4 times a day when we could, and kept this all up in track. So this is a comparison. In red is the 2022 eruption, and in brown is the 1984 eruption, which started off, if you look at it, started off almost identical to this eruption, but a fissure opened up lower on the Northeast Rift Zone, and that's where the lava flows went down towards Kaumauna. Instead, our lava flows followed the track of the 1935 eruption and went out into the saddle area and still remained about over 1.5 miles away from the road. The volumes were almost identical to the 1984, which is kind of surprising after 38 years. We're wondering if we might have another eruption a little bit sooner than that for the next one. But anyway, so here's the kind of things that we learned. We coordinated with the partners early and often. We communicated directly with the communities. We avoided the apocalypse scenarios, and we practiced caution sharing the lava flow model projections just to make sure that we controlled that message of where we think that lava was going, right? It's not that we were trying to withhold messaging from the public, but just to try and avoid these expectations of something that people think is going to be real. So we learned that the public real-time data was really invaluable to people in their homes to assess for themselves. And we need to do some things. We need to, you know, especially during the summit phase, we need to message more frequently. We need to actually repeat these messages about where is and is not threatened. We messaged early on that people in the Southwest Rift Zone don't have to worry, but we needed to repeat that message over and over again. Because once a rift zone is selected by the eruption, it's not going to jump back to the other rift zone. And then we need to just make the message stronger about, we know that when it hits flat ground, it's going to pile up. It's not going to move as fast. And so, you know, those are some things that we could emphasize. So that's what I have to share with you guys today. So I went a little bit longer than I thought I was going to, but I think there's a few minutes for questions if people have questions. It's up to Eric if I've got time for questions or not.
Yeah, we have time for questions. So does anybody, I know Amy's there and she's probably chomping at her bit to ask some questions. She's one of Bruce's former students. So I see Mike has a question. Let's see, Mike.
Oh, I have a question.
Okay.
I have a lot of questions, but I'll limit it. Thank you so much. This was very, very interesting and informative. I did have questions on the new technology, which you did kind of address. I was just wondering, I know you couldn't really put out the data due to security issues, but I was just wondering the data, especially with the phone, collecting that real-time information, was that really informative to help your decision-making on the USGS side?
Yeah, of course, we want to know where the lava is as often as we can. And that's what civil defense is most worried about. They really want to know where the lava is, and that really, it does. We were in the EOC that entire time. So getting that real-time information from the field without me having to call people and, send in a data point or something like that, to have it just show up on the maps there, then we could discuss it and keep all the fire, police, everybody that had to make decisions, the road crews, the state road crews, right? It was really important to have it in real time.
Okay, and I just have one more quick question. I was just wondering if there is any plans for potential like coastal evacuations, especially for towns like Miloli'i, like just in case there's a rapid road cutting eruption. Is coastal evacuation an option?
Is coastal evacuation, is that what you're saying?
Especially for towns like Miloli'i, just only one road in and out.
Yeah, so it, you know, I doubt that there would be coastal evacuations. I think because it's just Milili'i is possible because they do have a boat ramp and it tends to be calmer. Somebody suggested that, you know, we send people down to Pahui Bay on the south side, which is a 15-mile Jeep trail down to the, and there's nothing there except somewhat of a beach, which may be gone after this storm. But it would be possible there to take people out. But I think what would happen is the National Guard would summon lots of helicopters and we would helicopter everybody out of the area.
Thank
if
you.
it
I
got close.
never hear about it, so I was just wondering. Thank
Yeah,
you.
I think that was the main thing, is that there would be a number of helicopters brought over to bear on the problem, because there's quite a few big military helicopters on the islands.
Mahalo.
Hey, Mike, see you have your hand raised.
Yes, can you hear me?
Yes.
Okay, well, great presentation, Ken, thanks. I just had two questions, kind of at a higher level. You seem to, you've obviously, you guys have learned a lot there. Does what you learn apply to other volcanic activity around the world? And then the second part of the question is you seem to be pretty advanced with your tools and forecasting. How does that compare to other areas that have volcanic activity around the world?
Okay, the first question is, I think everybody struggles with this dance of how do you make sure the community is appropriately informed and knows what action to take without being alarmist and having it go out in the press as something that's highly alarming, right? So you got to have people respond to you. So I think that's something that all emergency managers struggle with in different various ways, but it's particularly difficult with volcanic activity because it can manifest itself in so many different ways. And we also tend to have these long run-ups, these anxiety building run-ups to things. So it's something we're all learning. We're actually having a meeting in Pucón, Chile, of all the world's volcano observatories to talk about these issues in November. So it's something, I'd say it's constantly evolving. We're learning from every single thing, and we tend to share our experiences with other folks. So in terms of the forecasting, we have it a little bit easier and a little bit harder than most people. One thing is we've studied Hawaiian volcanoes for so long. We understand a lot about their magmatic plumbing system. We have a lot of historical data to go on because the eruptions are so frequent. So we kind of know the patterns of these things, but it's like the Mauna Loa eruption, that was tricky to pick out that period, because if we would have picked out that period and nothing would have happened, and then we pick out another period, okay, you're going to be on edge for 3 months again. You know, you can only pull that trick so many times out of your hat, right? And it's not going to work. So we had to be pretty confident that we thought it was going into a stage that eruptive activity was, you know, a very high probable outcome of that stage of unrest. So there's a lot of uncertainty in there, though. We didn't know it was going to erupt, right? There's 38 years before that, and there'd been a lot of earthquakes before that, starting in 2014, and people kept saying, "Oh, it might be going to erupt. It might be going to erupt," and you know, so it's hard to say if we got lucky or if we're good, but we saw these combined earthquake activity and geodetic or deformation data that suggested that the magma moved up real shallow, and that's the thing that triggered our response.
Yep.
So Mary Sheridan asked in the chat, are drones used or are they too fragile in this type of event?
We didn't use drones very much in this event. During the daytime, which is when we operated, we didn't have to do any nighttime operations here. Really, we use helicopters because they cover a much bigger area, and we're up at 10,000 feet, right? So we had the drone out a couple of times to try and sample gas from the vent and a couple other things. that we did with it, but mostly we were working with helicopters. Drones would be extremely useful in a Southwest Rift Zone eruption if we can get drone big enough and has enough flight time that we can put them up pretty high in the air, that knowing where the vents are, if you have a nighttime eruption like this starts, you know, and you have vents starting to form at like midnight or something like that, being able to fly a drone when we can't fly other airborne aircraft out there would be advantageous. So there's definitely a role that's going to continue to evolve as drones get bigger and have, you know, more flight capacity.
I know during the Mauna Loa, there was like a flight restriction. And then, so we were trying to get permission, but by the time we went through all this process, it stopped already. So it was like, okay, never mind.
Yeah, and we had permission to fly our drones in there. So yeah, trying to get in with the COA, these are things that you need to have kind of in advance, you know.
Yeah,
So
yeah.
Park Service and Civil Defense worked with FAA to set up that TFR over the area. And that's so our helicopters could fly in there without worry of crashing
Yeah,
into
yeah.
other helicopters and stuff like that, I think, yeah.
I see Brian Woshon's on the call. I mean, he and I were talking about evacuation at one point when you guys were putting out the messaging about there's a possible eruption in Mauna Loa. But you know, you showed all those earthquakes down in the lower east rift zone. Was there any major evacuation during the 2018?
Well, people were told they should leave, particularly Leilani Estates, because, you know, we knew that the earthquakes were coming up under there, and then they had the first fissures, so they had pretty good visual warning too, the smaller fissures. But people are always, you know, hesitant to leave their homes, and I understand that. So there, but for the most part, when the eruption really started, most people did evacuate the area. The gas was so intense in that eruption that, you know, people aren't going to stay in the downwind part of the gas in there. But, you know, a lot of people stayed in the upper parts of Leilani Estates throughout the entire eruption.
Mike, you still have another question? Your mute's on.
Yeah, that answered my question. Thanks.
Okay. Is there anybody else? Dave?
Yeah, we're almost out of time here, so I'll be fast. Going back to an earlier slide in your presentation, you showed how the seismic events kind of propagate along a path until they get to a fissure where the pressure can be relieved. How accurately are you able to predict those paths of propagation?
Oh, we can track the earthquakes, you know, within 100 meters or so of where they are. So we're pretty, you know, maybe 200 meters at the most or something like that. So we're pretty good with that. So in the blind, that's what we would use to just see. But the earthquakes can be, they usually go ahead of the vent. They're at depth, so the crack is propagating at depth. And they can be up to 1 kilometer ahead of where the vent comes to the surface. So when that crack rises to the surface. So we don't always know exactly where that is. We do have infrasound microphones out around, but you know, the error in location there is not great. That what we realized that we had about 4 cameras up there, and we're going to replace them with streaming pan tilt zoom cameras, and we're going to put in more camera density along the Southwest Rift Zone. It doesn't matter too much around the Northeast Rift Zone because you've got days to respond to where the vent locates there. But on the Southwest Rift Zone, where you only have hours, we're going to probably double our camera density and put in much better cameras that we can move around that'll have 360 degrees and then can zoom in, put them in with, like, depending on what kind of power system we can get in there, either 10 or 20 times physical zooms on them.
Excellent. Thank you. That was a great presentation. Fascinating.
Thank you.
Any other questions? No, Amy probably has a lot more questions, but maybe you should ask questions, Amy.
I do. One of my biggest questions is on kind of to the 2018 Kilauea eruptions. I know you were part of Governor Ige's panel when deciding to shut down and move material from the Puna geothermal power plant. And I was just wondering, how was that decision-making process and what kind of role did you play?
I was doing the hazard advising for that. And Tom Travis, who was the associate director of HIEMA at that time, was the head of that panel. Supposedly Harry Kim was on it too, but Tom just communicated with Harry. Harry wasn't really part of that. But we had experts about geothermal from all over the country that came here, and they brought them in, FEMA brought them in and stuff, so that we had a lot of expertise in there. So the governor has set up two things. One is to get the pentane out of there, which is the secondary turbines were running on pentane, the heat exchange turbines. So they had to drain them all. And the governor's emergency proclamation made it possible for PGV to move it offsite because you're storing that amount of hazardous material offsite. So his proclamation allowed them to move it to Shipman. They also had to wait till they get the appropriate double-walled tanks that they could move it on the roads in. So that's what the hangup was with timing. It's wasn't really well reported in the news. They drain those things, which takes quite a while to drain all the pentane out of them and flush them so they don't explode. Right. And then moving the stuff, the proclamation really made it possible to get it off site. And so he issued that proclamation on the 8th, and I think they had it all moved into shipment on the 10th, by the 10th. The other thing we were doing was trying to make sure that there was no uncontrolled releases of geothermal fluids, sulfur dioxide, hydrogen sulfide from the geothermal wells. There were like 8 or 9 production wells there. And so starting on the 10th, we scrambled to plug all those wells and then cap them. And PGV designed their well field in a really cool way. There's big valves on the top of each one of those production wells. There's one that's up above the surface that all the power plant plumbing is connected to. There's also one that they can dig out that's below the surface. And so what they did was they dug all those out after we pumped the plugs, and we put these big metal plugs in the drill holes at about 2,500 feet in each one of the drill holes, and then packed them with mud on top of it. And this was just to protect against, over time, if this eruption produced significant reheating of the geothermal resource, that it might have caused those things to explode. And then if the tops over time rusted and weakened, then you might have an uncontrolled release of geothermal fluid. So we did a lot of damage to PGV's drill holes. We basically ruined all their production wells. We closed them all down. And then what they did with the valves at the top is they dug up the lower set, they shut those off after all the plumbing was done, and then they unbolted the upper valves off of that, and then they buried the lower one. So any lava flows that would cover the wells the wellhead would be insulated, because one of the things that happens to metal is when you heat it up with the lava flow, it loses its temper and stuff, and it starts to rust really easily. So this actually would keep the thermal degradation of the metal from happening as much. And it also made sure that, if you just left it all connected and it was connected to all the power plant plumbing and everything, that could rip or torque the top of the well. So being able to disconnect the top of the wellhead from the lower wellhead and have it shut off there and then just make that smooth ground, that meant the lava flow would just roll right over the top of it. And it might take and crumple all the other stuff, but who cares about that at that point, right? So that's what we, it was pretty amazing. We had to get a C5A, one of those huge military transports, to bring in 2 huge mud pumps from the mainland and then pump mud in there, and to close those things down, to get it done in 2 weeks before the Fissure 8 eruption was miraculous. That these guys that were working on it were amazing.
Thank you. Yeah, what's reported is it came, there's considerations, you got it done, but this was a lot more intensive. It sounds like it was a lot of fast decision making. So mahalo for explaining that.
It was a big group, and Tom ran it really well. He's an ex-submarine commander, and you could just tell he didn't get ruffled, and he really organized the meetings and went around the room getting people's opinions and stuff like that, and making sure that we had a consensus on what the next action should be.
Thank goodness.
Any other questions? We have somebody that just joined them. Thank Ken if there's no more questions. It was a great presentation. We look forward to everybody joining our next month's third Thursday.